Welcome to clickmyproject.com. Channel our Opportunistic transmission scheduling for energy efficient wireless links. The lifetime of a wireless device depends on the power consumption of the device, imposes a constraint on network performance. One of the most significant objectives in wireless communication network is to improve the autonomy of the terminal devices. The communication is much more energy efficient when the channel conditions are good. A novel distributed scheduler that opportunistically schedules the data transmission with a view of minimizing the energy consumption of a wireless device and prolonging its battery lifetime. The transmission takes place through the communication channel. The rate of the communication depends on the condition of the channel because the channel condition are time variant. The radio channel experiences both stochastic small scale fading and large scale fading. The small scale fading occurs due to multipath and the large scale fading due to shadowing. We focus on the communication energy assumption, particularly on the data transmission part, which is one of the most energy depending operations of a wireless device. To satisfy the specified power level at the receiver, the transmission power consumption varies strongly depending on the channel state of the wireless link. Considering that the communication is much more energy efficient when the channel conditions are good, we propose a multi-level queue scheduling to schedule the data with energy efficient. This is the overall flow of our project. Initially, the data which is to be scheduled is given as a feedback input to the fading channel, and this is scheduled by using the multi-level queue scheduling, and the energy consumption is calculated. The performance evaluation evaluated in the performance evaluation block. This is nothing but the data signal is nothing but the input data. In fading channel, in wireless communication, fading is a deviation of the attenuation affecting the signal over certain propagation media. The fading may vary with time, geographical position, or radio frequency. A fading channel is a communication channel comprising fading. Fading may either be due to multipath propagation or due to shadowing. And then the multi-level queue scheduling. Ready queue is partitioned into separate queues. Multi-level queue is separated into a foreground process and background process. Each queue follows different scheduling algorithms. It is used to improve the energy consumption. A priority number is associated with each process. The channel is allocated to the packets which packet has highest priority. Equal priority processes are scheduled in the FCFS order. In our process, we divide the ready queue into 3 different levels of queue. Each queue follows a different scheduling mechanism which conserves the energy better. In energy consumption, the lifetime of the batteries in wireless networks depends on the energy consumption of the devices. This energy consumption is effectively minimized using the multi-level queue scheduling. The energy consumption depends on the channel state because the channels are time variant. Energy consumption under various time interval, that is variable channel condition, is derived for multi-level queue scheduling. In performance evaluation, in this phase we introduce a multi-level queue scheduling to reduce energy consumption. Simulations show that our new scheduling technique consumes less power and prolonging the battery lifetime. We also compared our results with other scheduling algorithms like E²OTS, and the simulation shows that our scheduling algorithm consumes less power than the E²OTS algorithm. Open the source code folder and run main.m file. Here the command window displays the data transmitted in each and every queue. The figure 1 shows the time versus energy consumption of the PR1 queue data, and this figure 2 shows the energy consumption versus time in for the PR2 queue data, and it shows the PR3 queue data. We have divided the ready queue into 3 queues, so only we are putting the PR1, PR2, PR3. The figure 1 and 2, 3 results the corresponding energy consumption of the queues, and the figure 4 shows the overall dynamic multi-level priority queue energy consumption. And here comparison between the existing methods like E²OTS 1 and 2 and other methods optimal scheduling with our proposed algorithm. Compared to our existing method, our proposed algorithm consumes less power than the existing methods in the literature. From this, I conclude that our proposed method uses multi-level queue scheduling for wireless communication. This scheme uses 3 levels of priority queues to schedule the data based on their types and priorities. It ensures minimum end-to-end data transmission for the highest priority data while exhibiting acceptable fairness towards lowest priority data. Experimental results show that our proposed scheduling algorithm has better performance than the existing E2OT scheduler and optimal scheduler and other existing methods in the literature. Thank you.